Hello and welcome to NetApp Techtalk. Today we are going to discuss the features of NetApp's Cluster Data ONTAP operating system. Cluster Data ONTAP brings in the most sophisticated and state-of-the-art technologies that today's highly dynamic business demands. Today we have one of our Cluster Data ONTAP experts, Mr. Shiva Krishna, with us, who will talk more about this topic. Shiva is a knowledge development engineer in NetApp and has more than 8 years of experience with storage and virtualization. Welcome, Shiva.
It's my pleasure to be here, Pradeep.
So Shiva, tell me, what is this Cluster Data ONTAP all about?
Well, Pradeep, Cluster Data ONTAP is a new addition to a broad range of software products and is the core of all our technology offerings. As of Data ONTAP 8 and onwards, the Data ONTAP operating system can operate in either 7 mode or in cluster mode. 7 mode is the same as our Data ONTAP 7G environment, whereas cluster mode works in a different way altogether. There are many changes at the architecture level and at the user interface level. Cluster Data ONTAP provides a more user-friendly and easy command line interface and a nice GUI through NetApp's OnCommand system manager. Cluster Data ONTAP comes with almost all the features found in 7 mode, along with some additional features that were not previously possible to implement with traditional storage systems.
So what are the benefits our customers will see while using Cluster Data ONTAP?
The major benefits that our customers will see are in 3 areas. 1. Intelligent scale-out storage. 2. Non-disruptive operations. And 3. Better performance.
Could you explain those topics a little more in detail?
Sure. Let us talk about the scale-out architecture first. Conventional storage solutions allow customers to scale up their storage infrastructure by adding more memory, PCI cards, disk shelves, disks, etc. But at some point in time, the storage controller will be completely populated with no further expansion possible. In such scenarios, customers will have only 2 options. Either replace the old controller with a complete technology refresh, or run the new controller side by side with the original. Both of these options have significant disadvantages. In both of these scenarios, data migration is often required, as well as some client-side reconfiguration. This is time-consuming and sometimes disruptive too. With scale-out storage, we can add more storage controllers to the existing cluster to increase capacity and performance without much change to the existing environment. Volumes can be redistributed and moved across different nodes in the cluster to balance the load, and all these activities can be done without any planned downtime.
And that is where the non-disruptive operations help a lot?
That's right, Pradeep. Cluster Data ONTAP enables non-disruptive operations by being resilient to failures and by allowing you to change your storage infrastructure without any disruption. This is possible because rather than accessing physical resources directly, in Cluster Data ONTAP, all data goes through a logical construct called Storage Virtual Machine, or SVM. As a result, the physical resources used by an SVM can change without requiring any client-side or host-side disruptions.
What makes this possible? What kind of technology helps in achieving this kind of non-disruptive operations?
There are 3 standard features built into Data ONTAP that helps with implementing this: data motion for volumes, lift migration, and aggregate relocation. Data motion for volumes is also known as volume move operation. This allows you to move data volumes from one aggregate to another on the same or a different cluster node. Logical interfaces, also called lifts, virtualize the physical interfaces in Cluster Data ONTAP. Lift migration helps moving the logical interfaces from one network port to another on the same or a different cluster node. Aggregate relocation, also called ARL, allows you to transfer complete aggregates from one controller in an HA pair to the other without data movement. This is done by moving the ownership of all disks that are part of an aggregate from one storage controller to its HA partner, so that the partner node can still serve the data as if it was local to that controller until you migrate the aggregate back to the original controller.
What are the protocols supported by Cluster Data ONTAP?
The latest Cluster Data ONTAP supports wide range of data access protocols. such as NFS version 3, version 4, and version 4.1, including parallel NFS. When it comes to CIFS, SMB version 1, 2, 2.1, and SMB version 3, including support for non-disruptive failover in Microsoft Hyper-V and SQL environments. When it comes to SAN, we support iSCSI, Fiber Channel, and FCOE protocols.
What are the features supported as part of storage efficiency and data protection?
That's a very good question, Pradeep. Cluster Data ONTAP now supports thin provisioning, NetApp snapshot copies, NetApp Flex clone volumes, NetApp Flex cache volumes, deduplication, compression, NetApp Snap Mirror technology, and NetApp Snap Vault technology. All these features are now supported on Cluster Data ONTAP.
So when we talk about performance, do we have any performance improvements with Cluster Data ONTAP?
Yes. In 7 mode, all the data exchange activities were done by only 2 storage controllers, and in case if one of them fails, the surviving node has to take all the load on its interfaces. With Cluster Data ONTAP, we can have many nodes serving data through several physical interfaces. And also, we can have load sharing mirrors for all the volumes residing at several physical nodes, each of them serving a copy of data through the mirrors of the original volume. Another feature that greatly affects performance is Data ONTAP's quality of service policies. Using QoS, we can limit the resources that can be consumed by an SVM, a volume, a file, or a LUN so that no single component will eat up all the resources, thereby allowing all components in the cluster to get fair share of available resources. In addition to this, Cluster Data ONTAP supports features like flash pools, intra-cluster flex cache, branch cache, all of which help to improve performance to a great extent.
So when we talk about limitations, what are the storage limitations of cluster mode storage system?
It really depends on several factors. These limits change from ONTAP release to release. It also depends on the hardware platform that you're using. Currently, we support up to 8 nodes with a maximum capacity of 23 petabytes in a cluster where SAN protocols are used, and up to 24 nodes with a maximum capacity of 69 petabytes in a cluster that uses only NAS protocols. To get more recent information, you may consider using NetApp's hardware universe. When it comes to a single volume, current limit is 100 TB per flex volume, and this is again platform dependent. There is also another feature called infinite volumes. Infinite volume is a type of volume that is contained in a dedicated SVM, which can scale up to 20 petabytes and store up to 2 billion files. In Cluster Data ONTAP 8.2, infinite volumes can coexist with standard SVMs and support both NFS and SMB client access.
Well, I'm planning to buy a NetApp storage system. Due to budget constraints, I can afford only one node at this time. Should I choose 7 mode or cluster mode?
That's the beauty of Cluster Data ONTAP, Pradeep. From version Cluster Data ONTAP 8.2 onwards, we support single node clusters and 2 node switchless clusters. You can start with single node now and can scale it out up to 24 nodes for NAS and 8 nodes for SAN.
Is the Cluster Data ONTAP cloud ready? How good are we with multi-tenant environments?
Storage controllers independent of the model are considered equivalent in the cluster configuration. The cluster is made up of all the physical resources such as storage controllers, disks, aggregates, network cards, HPS, etc. The cluster itself doesn't provide any data services. As I mentioned before, within the cluster the data is actually stored and served by a logical construct called Storage Virtual Machine or SVM. SVMs own all the data volumes, LUNs, and serve the data to the clients through logical interfaces. Administration of each SVM can optionally be delegated so that separate administrators are responsible for provisioning volumes and other SVM specific operations. This is particularly appropriate for multi-tenant environments or where workload separation is desired. An SVM delegated administrator would have visibility only to his or her specific SVM, so have no knowledge of any other hosted SVMs. By virtualizing physical resources into the SVM construct, Cluster Data ONTAP implements multi-tenancy and scale-out. So I can say it is a cloud ready.
Well, thank you Shiva for giving us some insight on the features of Cluster Data ONTAP operating system.
Thanks for giving me this opportunity, Pradeep.
You can watch other technical videos on NetApp technologies here on KBTV. We would love to hear from you. If you have any questions or feedback, please leave a comment below. For technical queries, you can visit the NetApp support community forums. You can also reach out to us on Twitter. Links to these can be found in the description section below. Thank you all for joining us today at NetApp Tech Talk.